Noelle will now show us how she teaches the commutative property to 7th graders.
When students are learning the commutative property, I have to keep in mind that they will learn several properties in 7th grade, and we want to make sure that each one they have an opportunity to build an understanding for, so they will be able to identify the property as well as differentiate between the properties. So when I start the process, the first step is to provide them with some ideas and examples and descriptions of what the commutative property is. So I like to start from where the students are, and a lot of times that means concrete learners. So we're going to use inch tiles, though you could use cubes or whatever you have handy. And I'm going to start to very simply, and Lois, if you'll help me out, tell me what you see.
3 yellow tiles.
Okay, and?
2 green tiles. 3 green tiles. 4 green tiles.
Okay, 4 green tiles. And what do we have all together?
7 tiles.
Okay, all right, let's look at that a slightly different way.
4 green tiles.
And?
3 yellow tiles.
And all together?
7 tiles.
Not very tricky, right?
Not really.
Not really. And the students will start off with the idea that that's not very tricky at all. But you need to do this several times, because what we want them to do is to see the pattern and to be able to form the generalization and therefore define the property. So let's try one more.
2 red tiles.
And?
3 green tiles.
Okay, and what do you see all together?
5 tiles.
Let's go ahead and record this. Now with students, you may have to do several manipulative examples and kind of gauge where your students are in their thinking. But what I see there is I have 2 reds and
3 green.
3 greens, and total of?
5 tiles.
Okay, so 2 plus 3 is 5. And let's take a look at another one. All right, what do you have?
3 green.
And?
2 red.
And all together?
5 altogether.
All right, so let's record that. We have 3 green and 2 red and altogether 5. So what do you notice about those number sentences?
Well, each equation has the same addends, 3 and 2. They're just switched, and they both equal to 5.
Okay. And what I would probably do at this time is ask students to come up and make up some of their own examples and come to the overhead and demonstrate them, and also write number sentences. Now, you just basically, in your own words, stated the commutative property. So we want to capture that thinking. Okay, so it's time to move to step 2. And in step 2, it's when we give the students the opportunity to capture that thinking in some sort of note-taking form. Mm-hmm. One that I have here is a foldable, and basically I was thinking of doing 2 properties at this time. Now that you have some ideas, the teacher can provide that label. Okay, the kids form the ideas, the teacher provides the label to kind of to allow us to talk about it, and so the commutative property. And inside we have the Freier model. Okay, the kids would capture their words right here, putting it in their own words that make sense to them. They would come up with some non-linguistic representation, a picture, because our brain not only remembers words but also remembers pictures. So it will allow us to recall that information later on if we have some non-linguistic representations as well as words to capture that understanding. And then some examples and some non-examples. So they're completing all of this very thorough way of looking at the commutative property. Okay? After they've captured their thinking, what we want to do is we want to give them an opportunity to work with the property. One thing that we see 7th graders needing to do often is to add a string of integers. Now certainly this string of integers could be added straight across, but the commutative property actually allows us to reorder those add-ins and make it a simpler problem. Now we have 7 plus -3 and the result of 4. So because of the commutative property, we can do that. And it's very important. Students may not jump to that conclusion. It's very important that we make that explicit and help make that connection. Well, why are we learning the commutative property? Because it makes mathematics simpler for us. So it would be a good idea to give them some examples and then have them create some of their own, where the commutative property would be helpful. Okay. The next step would be to discuss the terms with each other. And at that point, I'd ask them to take their foldable and sit down with a partner and talk about, well, what was your non-linguistic representation and why does that mean commutative property to you? And what were your words? And maybe I can add to my definition. Maybe you use the word add-in and I use the word numbers, and I can add some more depth to my definition based on that conversation. When students can talk about words and talk about mathematics, the understanding is much more deep. And finally, we want students to play. We want math words to become a part of their vernacular. We want them to become part of the way that we talk in a mathematics classroom. And so we give them opportunities to play with the words, whether it be through word walls or whether it be through sorting activities or matching games. But keep the language alive, keep the properties alive throughout the school year.